In the case of chlorine, again, the outermost shell has a deficiency of one electron, and this has a deficiency of one electron. The octet is not completed, and if they share, each ion of chlorine share one electron from the outermost shell, then what will happen? You will get this situation. So again, remember, I am stressing upon this again and again, that the electron never goes away from whose it was, but it was shared with someone who also shared the electron with the same, and they completed octet, and that completed octet. And because of the completion of octet, the energy before the bond was higher than the energy after the bond. When the energy after the bond is lower, this means attraction is there. The molecule will be there, it will survive. But if after sharing this electron, the energy jumps up, then they will repel each other. And that is why they are not going into each other. They are keeping the same distance always, and you have fixed bond lengths in specific compounds in this manner. I think I have tried my best to explain that conceptually. Consider it that none is losing electron, but they are sharing electron. In the ionic bonding, the electron, the one has excess electron, the one has deficiency in electron. Here, both are deficient of one electron. There, the electron was transferred to that because it was needed there, but that share, outer shell was also shared, and none lost nothing actually, but the bond was made, but the electronegativity made the one needing heavier and the one giving lighter. But still, the electron is the reason for bonding. Is I gave you the example of marriage, that the bride was transferred from one home to another, but it never left, or it doesn't mean that she left completely her parents, but she was transferred, but the relationship was established. A very strong relationship was established. But in friendship, people come and go. They are not completely transferred to each other houses. And that sort of bonding is called covalent bonding, because they are friends, they come together in the meeting place at a specific time and go back to their homes. Here, when the pair of electrons is here, they look to be with both of them, and then they move around in the orbits and keep the atom and the atoms together to form the molecules. Resonance leads to electron promotion or hybridization. For example, for carbon, it has a helium configuration with 4 electrons in the second shell, 2s2 and 2p2. In this case, electrons will normally occupy the 2s2, 2px1 and 2py1. So 4 electrons are in the p subshell and 2 electrons are in the s. But if we say that it is 2p2, then we are increasing the energy. We are compromising the attraction. But if the shells are different, then the states can be different. You will understand it when we move forward. However, by promoting an electron from 2s to 2pz, for example here, the atom can create 4 new energy states. So you increase the number of states from 3 to 4 to S1, 2p1x, 2px1, 2py1, and 2pz1. There are then 24 ways to distribute these 4 electrons into the 4 available states. Which electron goes to which substate, and the atom can resonate among these states. So electrons are not something that when you associated them into a specific orbit, they will be fixed there. No, they resonate between various shells and play the role needed from them. The more degenerate states available to a system, the more likely it will be for the system to be in one of these states. Degenerate. In the case of carbon, sp3 hybridized orbital is formed to accommodate 4 electrons with parallel spins, and sometimes antiparallel spins, and that is why you, for example, if you have the only choice of parallel spin, then you can accommodate 4 electrons in the sp3 hybridized orbital, and that resonation, that is, the electron is not exactly, but it is shared exactly with its original position as well as in the resonant cell, and that is why they minimize the energy and keep their diamond. In the case of diamond, these 4 orbitals extend into space with mutual angles of 109.5 degree, forming a tetrahedral. Not tetrahedrals. The plural of tetrahedral is tetrahedra, and that is why I have intentionally put an S there to tell you that we always do certain mistakes, grammatical in spellings. The plural of tetrahedral is tetrahedra. The plural of formula is not formulas but formulae, and similarly octahedra and different things. Each of the 4 electrons form a covalent bond with another atom. Now, if you have 4 orbitals, outermost orbitals, and you have 4 nearest neighboring same non-metal ions, then you need 4 junctions to tie the ion along the 4 directions. So when you have 4 electrons in the carbon in the outermost shell and 4 ions are surrounding them, then each electron will be shared with each electron of that particular orbit, and the carbon ion will be tightly bound or tightly bonded between the neighboring 4 carbon atoms at specific angles, and that is why diamond is the hardest material. The more the bonds, the stronger the bonds, the harder the material, the higher the melting point, and that's it. Electronegativity is a measure of how strongly the atoms attract electrons in a bond. The larger the electronegativity difference, the more polar will be the bond. What is polarity? When the bond is attracted more towards one atom in comparison to the other, that will lead to polarity. One will be more positive than the other. If they are equivalent, -1 +1, then they are equivalent. But if one is -6 and the other is -1, then obviously the bond will be tilted towards the higher electronegativity ion. The larger the electronegativity difference, the more polar the bond will be. And when the electronegativity difference is between zero point 0.0 to zero point 0.3, the covalent non-polar bond will form. They will almost equal sharing between the two. If the electronegativity difference between two elements is zero point 0.3 to 1.67, then the covalent bond, but it will be polar, more inclined towards the higher electronegativity element. And if it is above 1.67, if the electronegativity is above 1.67, then an ionic bond will form. How to show a bond is polar? More electropositive or more electronegative. Instead of a whole charge, we may have partial charge. So this sigma, or whatever you call this symbol, plus means a partially positive. When this symbol was not there, it was totally, entirely positive. But now it is partially positive. So one atom or ion, but ion I think will be more electropositive than an other. Similarly, an ion will be more electronegative than an other. This more brings the partiality into the size, means a partial negative, and that one partial positive. The chlorine pulls harder on the electrons. So the sharing is inclined towards chlorine because of its higher electronegativity. The electrons spend more time near the chlorine. So this means it's not totally with chlorine, but spends more time. If you remember, I showed you the orbits were equal when both the bonding ions were chlorine ions because they were equally pulling, equally attracting the electrons towards them, and they were in the center. But now, when one is electropositive and the other is electronegative, and the electronegativity of chlorine is more, then the electron will spend more time with the chlorine, and this will lead to a polar type of bonding. Non-polar covalent bonds when electrons are shared equally, and polar covalent bonds when electrons are shared unequally, such as in hydrogen and chlorine. When hydrogen atom is bonded with another hydrogen, or chlorine is bonded with another chlorine, there they are shared equally, and the covalent bond will be non-polar. But if, as I showed you, in the case of H2O, such as in H2O, the hydrogen side is electropositive, oxygen is electronegative, and the bond will be more towards the bond will be polar. So water is a polar molecule, and that is why in microwave you utilize its polarity. Because oxygen is more electronegative than hydrogen, and therefore electrons are pulled closer towards the oxygen. Here, they don't seem to be closer to the hydrogen, but towards the oxygen. That induces. So this part, actually, scientifically, this part is more electropositive and this part is more electronegative. So instead of a spherical configuration, which you used to get, you are getting an deformed sphere or elastical type configuration to introduce polarity. A little bit details about the metallic bonds. The bonds found in metals holds metal ions together very strongly. They are formed between metallic elements. Metal, non-metal bond via ionic bonding. Non-metal bond via covalent bonding. And metal-metal bonds are metallic bonds. Electron cloud around atom. Good conductors at all states. Lustrous, shiny. Very high melting points because of the strong strength of the bonds. And the common example of metals are sodium, iron, aluminum, gold, and cobalt. Now, let me further explain this. Metals, we consider metals are like visualize metallic atoms as nuclei are positive centers of atom floating in a sea of electron. Electron cannot be free, but we say that there are so many electrons that they are considered almost free, not totally free, almost free. So you don't know which how many electrons are bonded to how many nuclei, and that multiple bonding gives the strength to the metals. Now, if I bend a metallic component and it was bonded by 2 or 3 electrons and I had broken those bonds, then the metal should not be ductile. It should break like ceramics. It should break like glass. It should break like graphite pencil. But no, it bends. This bending means that the bonds are not broken abruptly. But if that nucleus and that nucleus were bonded here, now they are bonded by some other pair of electrons, and sequentially we bend the material, which we say they are undergoing plastic deformation. So plastic deformation is not possible in ceramics, but it is possible in metals because of the metallic bonding. Metals do not combine, they form alloys, which is a solution of a metal in a metal. Examples are steel, brass, and bronze. The people form alloys because to enhance property consist of closely packed cations floating in a sea of electrons, as I told you. Then all of the atoms are able to. The electrons are not bound to individual atoms, so metallic bond form between atoms of metallic elements. Electron cloud is always there around the atoms, and that holds metallic atom together very strongly. And as I told you, they are lustrous and conductors in all states. Metallic bond formed between an array of positive charged metallic cations and a C. Now note this, there a single electron transfer was forming a bond. A couple of electron sharing was forming the bond in covalent case. Single electron transfer was forming a double electron, but the number was known and it was very small in comparison to metal, which was included in the bonds. But in the case of metals, it is basically an array of positive nuclei which are bonded in a sea of electrons. And that is the reason for the strength of metallic. Almost free, never free. Almost free, never means free, because the electron cannot be free like that, but they are can be easily removed from one ion are dissociated from one ion to go to the other. The free electrons being donated by the outer shells of the constituent atoms and metallic bonds are non-directional. Note that occurs for all metallic elements and their alloys. I said metal don't combine with metal, but they form alloys. So alloys need a little bit explanation because you are enhancing specific properties by mixing one metal in another. So three things came into the mind. A mixture, which is physically mixing of one material in another. Solid solution. Solid solution means that you introduce new ions, cations, into an already solid structure, and that is chemically bonded. And alloys, which are metallically bonded. There is a large difference between the chemically bonded and metallically bonded. Chemically bonded means the electron was transferred from one ion to another and the bond was established between the two. But in alloys, you introduce a cation into the row of cation into an array of cation and it was bonded in the metallic fashion. So this is the difference between the alloys. Metallic bond arise from the electrostatic attraction between the cation cores and an electronic cloud. Not electron, but electronic cloud. Note that. An electronic cloud contains many electrons. The electrons are said to be delocalized because they are not confined to any specific cation core but are free to move, almost free to move between the cation cores. Hence, the metallic bond is non-directional. You cannot associate a specific electron to a specific cation, but they are constantly moving, oscillating, vibrating, and that is why metals are malleable. When you bend them, they bend, deformable, can undergo elastic and plastic deformation because of this character, because of the sea of electrons. In metals, electrons are free to move through the solid, therefore conduct electricity. Hammered into shape because of malleability. They can be bent. Ductile, drawn into wires. You can thin down them and make wires of metals. But if a ceramic material is thinned down, it will be brittle and will. So compressive stress wise, ceramics are very strong materials, and that is why you are making building structures from them, from blocks and bricks and marble and things like that. But when there is a little bit tensile pressure, it comes to bending, then you put the metallic rods in your roofs in order to cope with the tensile stresses expected upon the building. So that is the quality. They form alloy, and it is a solid solution of a metal in a metal. Solid solution and mixture. Solid solution means that they are bonded and there is a limit for solid solubility of material. For example, I am giving an example which is not the, both are not the metals. One is water and sodium chloride. When you put sodium chloride salt in water, it is completely dissolved in water. But after a certain limit, the sodium chloride or sugar or whatever solid you put, it settles at the bottom and you can clearly see the solubility limit of sugar or salt in that liquid, whatever you were using. Here, you can make an alloy, but up to a certain limit of one element can be solidly soluble in the other element. And when that happens, people say the solid solubility limit has been crossed and the phase is no more that phase, but it will form a different phase. For example, if each iron atom can make a solid solution with only one copper atom, and you are increasing the number of copper atoms so that the number of copper atom exceeds that of iron atom, what will happen? It will form FeCu2 type thing. So it will not be FeCu, and that will be a second phase. In Alloy, the phase is single. It is not two-phase material. It is a single-phase material throughout, and that is why the solid solubility limit is important. At introductory level, I think this is enough regarding the burning. And this is an important point that electrons act as a lubricant, allowing cations to move past one another. Again, plastic deformation. And I'll come to these in the crystallography section. And thank you very much for listening. We will go to the crystallography section in the next. In the previous lecture, we were in crystallography, and here I will recheck that if we need anything more from bonding, otherwise we will move towards defects in order. And that when we are speaking, we always confuse things. Sometimes with a slip of tongue, if I call positive a negative and negative a positive, the student will be really confused. So this is very important to read books, because books are time and again checked and such mistakes are minimum there, and books are the main source. For example, if you ask me a question that what is the definition of a microscope, and I simply tell you that microscope is an instrument which can resolve things unresolvable with a naked eye. You declare me a very intelligent teacher and say that this teacher is very, very expert because I told you the simplest and the shortest definition, and your problem you think was solved. No. If I tell you that go to the library and there is a book on microscopy, there will be a chapter, 10 chapters in that book. At the end of each chapter, there will be 10 to 20 references. And there is a, with going to the book, you have opened, or the teacher has guided you to open for you a new world of microscopy. So the lessons, the knowledge, it is not that much limited that you hear something from the teacher and that's it. No, read multiple of books as a student, and every author has his or her own quality. There will be many topics which you will not understand from one book, but when you read it in another book, you will more clearly understand that, and in this way you can increase your knowledge. So never limit your knowledge to the teacher lecture alone. Read books and expand your knowledge, and that will give you confidence and strength in your future. Good luck. Thank you very much for listening. Bye bye.